Hello guys, so we are going to continue the discussion with respect to statistics, and in this video we are going to discuss about power law distribution, which is again a new distribution which is not a Gaussian distribution, and we'll try to understand how this distribution basically works and what all kind of data set probably follows this kind of distribution and what this probability distribution conveys, what kind of information it conveys of a specific data set. So without wasting any time, let's go ahead, and first of all we will definitely start with the definition. So in power law distribution, the first thing you need to know is about the definition. Obviously, in statistics, a power law is a functional relationship between two quantities where a relative change in one quantity results in a proportional relative change in the other quantity. Independent of the initial size of the quantities, one quantity varies as the power of another quantity. Now, again, the definition, as usual, it is complex. Every topic that we probably learn in statistics, the definition is quite complex. So it is better we learn it with the help of examples. I give you a lot of examples and then we'll try to understand. Okay. Let's focus now on this diagram. Okay, so this diagram will actually help you understand about the power law distribution. Whenever we talk about power law distribution, you really need to remember 80-20% rule. Okay. Now this is how a curve will look like. You know that for a normal distribution, my curve will look like this, right? For log normal distribution, my curve will look like this. You know about Bernoulli distribution, you know about binomial distribution and all, right? So this is specifically a normal distribution. This is specifically a log normal distribution. Now you know it. Now whenever you get this kind of curve, then you specifically talk about this, or you call this as power law distribution. Now, why this curve is basically following a power law distribution? It follows this 80-20% rule. Now, what is this 80-20% rule? Now, you can see with respect to this variable and this variable, the relationship between them is like this is first of all covering 20% over here, and remaining this is basically covering the 80%, right? So here you can basically clearly see that how this 80-20% rule is with respect to two variables that are probably present in the x and y axis, right? So this is super important. It is just trying to show you the relationship between one variable to the other variable. When we say this particular variable, see, a relative change in one quantity results in the proportional relative change in the other. And if you probably see the last statement, one quantity varies as the power of another, right? So whenever you have this kind of relationship, it is basically called as 80-20% rule. Now with respect to this particular variable, you can see that it is trying to take up 20% of this entire area, right? And remaining all will be basically this 80% of this entire area, right? So this is how a relationship basically looks like. To the right, we specifically say it as a long tail, and to the left, there are few that dominate, so also known as 80-20% rule. Now, if I probably talk about some of the examples of a specific data set that follow power law distribution, because unless and until you don't understand these examples, you'll not be able to relate it. Okay, I hope everybody has seen IPL, Indian Premier League, right? Can we probably talk about like 20% of team in most of the matches is responsible in for winning 80% of the match, winning 80% of the match. So obviously this is true. This is my first example over here. Now let's talk about the second example. Now second example, what you can probably talk about. Now see, in IPL, obviously you have seen, right? 20% of the team, right? They play absolutely fine to win the 80% of the match, right? Now the second example can be 80% of wealth, right? Are probably distributed with 20% of people, with 20% of the total population, let's say. Okay, so this can also be a very good example that may follow this kind of distribution that is basically called as power law distribution. Let's talk about the third example, right? Now, if I probably consider about the third example, so you can probably say 80% of the total oil, okay, crude oil is with 20% of the total nations, right, of the nation, right? So this can also be a perfect example in understanding the specific power law. If I give you more examples, then also you'll be able to see The fourth example, I can probably talk about the frequencies of words, right, in most languages. So this also probably follows an 80-20% rule, right? So like this, just think of different examples. What do you think with respect to 80 to 20% rule? Let's say in IT companies, what kind of example we can specifically say? We can probably say that 20% of the major defects, right, fixes the 80% of upcoming defects, right? So because of this 20% defects, other defects may also get raised, right, in a product, in a software product. So this can also be a perfect example. Okay. Now, one very important thing that we specifically know, right? Whenever we have a log normal distributed, right? And if we apply logarithmic, right? Like log to the base e for this x random variable, then we will definitely get a normal distribution, right? Only if this particular distribution is follow a log normal distribution. Why do we do this? Because in machine learning algorithms, there are many machine learning algorithms which want the data to fall as a normal distribution, right? They want to specifically fall as a normal distribution so that the machine learning algorithm will be able to perform well, right? Similarly, what if I have a power law distributed data, which will look like this? Can we convert this into a normal distribution? So this is the question that we specifically have, and the answer is yes. For this, we specifically use Box-Cox transform. And again, don't worry, we will see this in the upcoming videos, how exactly Box-Cox transformation is done. This is also one kind of transformation, like how we have log transformation, we have probably standard normalization, like standardization, all this kind of are transformation techniques, right? Now, whenever any data which follows this kind of power law distribution, we specifically call this as Pareto distribution. Okay. So in my next video, we will try to understand about Pareto distribution. But in short, this basically follows again a 80-20% rule. Okay. It follows the power law distribution. And if we probably apply a Box-Cox transform to this kind of data, we will be able to get a normal distribution. In order to validate a normal distribution, we can use QQ plot, right?